All right. Welcome, welcome, welcome to Berkeley Law. Welcome to the 2026 California Law Review Symposium. Welcome to the, as far as we know, world's first symposium on surveillance, prices, and wages. My name is Ted Mermin. I run the Center for Consumer Law and Economic Justice here at the Berkeley Law School. We are extremely excited to have with us today stars from across the country, around the world, on live stream, and a bunch of speakers that I think that all of us are very eager to hear from. It is a tremendous privilege to have all of you here. It is a particular privilege to be standing up here with the folks who have made this day happen. The first of those I want to hand over the mic to is Christina Chung from our own Center for Law and Work.
Good morning, everyone. I just wanted to thank everyone for coming to this event. It's a great privilege to be here, to listen and learn from the wonderful array of speakers who are such incredible thought leaders on this critical issue. So again, warmest welcome to everyone. Thank you for coming to a day that promises to be full of thought-provoking and robust discussion.
And then from the California Law Review itself, DeShawn Carter.
Thank you. Thank you. Hello, everyone. Again, my name is DeShawn Carter. I am the Symposium editor for the California Law Review, and I have the esteemed pleasure to be working with the Berkeley Center for Consumer Law, Economic Justice, and the Berkeley Center for Law and Work. Ooh, I practiced that a little bit. It is really exciting every year for the California Law Review to host these symposiums, but not only that, it is also very exciting to choose from the dozen symposiums that the California Law Reviews accepts. We get subjects ranging from criminal law to family law to environmental law, and even the exciting tax law. And in deciding which symposium we decide to pick, even though the California Law Review does change its leadership every year, what remains the same and what is always kept consistent is that we host symposiums that bring the law closer to the people. And that is what this symposium does. So it is with an extreme pleasure that the California Law Review is a proud partner of this symposium event. And I want to hand it off to Iman.
Oh. No, this is right.
Yes.
This is your real MC.
Thank you, DeShawn. Yeah, hi everyone. I'm Iman Eslami. I'm a 3L at Berkeley Law, and I'm also a student legal fellow with the Center for Consumer Law and Economic Justice. It's been an honor to work on this event. Almost a year ago, Ted brought it up in a meeting with his student legal fellows that they needed somebody to help out with the Surveillance, Prices, and Wages Symposium. I raised my hand, and I've been on a journey ever since. Meeting so many wonderful luminaries in this field. Thank you, Seth, Sam, and Doha, who couldn't make it, for guiding me along the way. And thank you for Ted for giving me the opportunity to work on this amazing symposium. I'm so glad you all could make it. Please let me know if you have any questions throughout the day. We'll all be around, but thank you all for being here. And it's my pleasure to work on this event and bring it to life. So thank you all.
Iman's work has been incredible. The first half of the year, he was actually in DC, so he was doing this entirely remotely. We're very glad to have you here. Another person who was unable to be here today, but is here in spirit and working, in fact, behind the scenes, if you pull back the curtain, is Ben Hebert, who is the person who's really the guy with his hands on the controls. So thank you, Ben Hebert, for making this happen. The Director of Operations at the Center for Consumer Law and Economic Justice. And then just briefly, we will hear a little bit about the genesis of this symposium. A year ago, we were sitting around calmly at the center, minding our own business, when a trio of luminaries from the East approached us. And Seth Frotman, Sam Levine, and Doha Meki joined the center as senior fellows, which has been an incredibly enriching experience for all of us, for students, faculty, and the nation, to have them working with us. Doha is not here today. We wanted to have a little her face on a little stick that we could hold up for all the things that she has done. But she said something about her brother getting married tomorrow, and so she had to be there. But we do today have Seth Frotman to tell us a little bit about where all this came from. So thank you, Seth.
Sure. I wanted to start, though, by echoing what Ted said about the wonderful experience it has been getting to work with students. I think for a lot of us who work in the law, think about the law, care about the law, these are like incredibly challenging times. And to get an opportunity to work with Iman and DeShawn and the whole team gives you the sense of, maybe things will be all right at some point. So it's been like a really just wonderful experience. These are definitely duties as assigned for them on top of all of their other work, and they've just been wonderful to work with. So as Ted mentioned, around a year ago, Sam and Doha and I were thinking about something that we could try to do to be helpful to the world. And we were trying to really think about a really big idea that was impacting working people. And we really wanted to kind of think about a topic that joined together a whole bunch of different issues that we had worked on, from consumer protection issues to antitrust issues to privacy issues, one that touched individual consumers' lives and workers' lives. On top of it, something where we thought that there was really kind of a dearth of serious scholarship or focus about how we can make working lives better. And I think with a lot of work by the students, by Sam and Doha, we landed on this idea that surveillance pricing and surveillance wages were something that we could try to pull together the best and brightest people to make a difference. And that's really the genesis of today's conference. And one of the things that we really wanted to focus on, and I think you'll see this by the panels, is we wanted to think about ways in which we could be using the law right now, not some far off, distant, no offense to the Academics Law Review article in the future, or some bill that passes in the year 2075 or whatever, but how should public litigators, private litigators be thinking about ways in which we could use current laws on the books at the federal, state level to protect workers and consumers from some pretty egregious practices we'll hear about. But then also recognizing, while that's likely not enough, and how do we put the kind of best and brightest in the room, from academics to researchers to people who are battling it out on the front lines of state legislatures across the country, and help arm them with kind of what are the tools that real people need to fight back against a lot of the abuses we'll hear today. So the goal is that this is really a working session, and I think you're going to hear a lot of really profound comments back and forth from people across kind of the whole range of philanthropy, academics, researchers, litigators, lawmakers, et cetera. Some of those folks are watching at home, and the idea is for people to really think about ways that they could protect working people. So we're just so appreciative that you guys are all here today or spending some time watching on the phone, and with that, I'll shut up.
Thank you. All right. I think we are ready for our first session, so thank you very much, organizers. A round of applause, please, for the people who made this happen today. So our first session is with Professor Park Sinchaisri. He's an assistant professor of operations and IT management at our very own UC Berkeley Haas School of Business. Professor Sinchaisri's research examines how firms and digital platforms use pricing, incentives, and algorithmic systems to shape behavior and outcomes in modern markets. His academic credentials are snazzy, and you can read about them in the digital program. We are privileged, thanks in particular to Doha Meki, to have Professor Sinchaisri here to level set, to provide the economic and technological foundation for the conversation that will occur over the course of the day. In other words, we have asked Professor Sinchaisri to give us all a brief look inside the machine. That is, why and how businesses engage in personalized pricing and wages. I will say, if you have questions, our remarkable team will be passing out index cards and pencils if you need them. And you can write your questions down. They'll be passed up to me for this session, to moderators for other sessions. Please feel free to generate those questions over the course of the day. Park, welcome. Take it away.
All right, good morning, everyone. My name is Park Sinchaisri. I'm from UC Berkeley Haas School of Business. I'm actually from the Operations and IT Management Group. I'm super excited to be here, so thank you so much for having me. Partially because I think the topic we're going to talk about today is exactly the kind of topic where law, economics, operations, and technology are basically looking at the same object from different angles. And in fact, I'm happy to chat with you offline also on my other research on incentive on platforms. But today, we're going to try to do a 101 level of how companies or platforms think about pricing digitally, right? And so I'm not going to tell you, in fact, I probably know the least legal stuff in this room. So I'm not going to tell you what the law should be, but I'm going to try to help you understand the machinery behind all these pricing, right, to make it less mysterious. So I think the key point of today is that this is not a new question, right? Companies have traditionally been trying to segment customers for a really long time. They want to know who willing to pay more, who willing to pay less, who should get a discount, right? If you go back to the old days where we have traditional coupons, right? Anyone still remember the coupons from the old days? Yeah, it's kind of fun, right? Coupons by themselves are not just a discount, right? It's actually also a screening device. People have to clip the coupons from the newspapers or that kind of machine, and then they have to remember to carry them into the stores and use them, right? Doing so reveals so much about their price sensitivity. And so this is not a new question, right? In the old days, people already changed prices, but with the friction, right? All this friction on both sides, for the company to change prices, for the consumers to follow up on these coupons. If you fast forward to nowadays, right, we have all these apps like Safeway on the left, McDonald's on the right, no longer physical coupons, right on your phone, right? Now, these promotions can be influenced by where you're currently at, right? Can be about your past behavior, past purchases. On Reddit, there's a husband and wife couple who posted this. They were sitting next to each other at McDonald's, and they look at these 20 pieces of chicken nuggets, and it turns out they actually get different prices, right? And so the striking thing here is that now you can do this at a very granular level, right? All the millions of customers, every single location, every single time step. And so the question we're going to think about today is, now that things become more digital, right, it reduces all the friction. How have the companies been advancing in this front? If you think about 2014, back in February, anyone have heard of this news story of Wendy's was trying to experiment a little bit with search pricing. So in one of their earnings call, the previous CEO mentioned that we are trying to, testing more enhanced features like dynamic pricing and day part offering. So coming from operations, that's not a new thing at all, right? We have happy hours pricing before, we have hotels, airlines doing this. But as you can imagine, right, when customers see this kind of news, the reaction was pretty immediate. Right? You get a lot of headlines saying that, wow, this is like Uber for burgers. Customers are like, are they going to charge me more when I'm hungry? Burger King had actually a really cool response. They said, no urge to search at Burger King. pretty cool response, right? In fact, knowing this, right, you're going to see later that doing this kind of personalized pricing, it's actually quite rational from a business perspective. But you have to be very, very careful in implementing them, right? Otherwise, we get this reputation explosion here. And so within one day, they said, actually, we're not doing that anymore, right? And so you all may have heard the FTC has this definition for surveillance pricing, right? Whenever platforms or companies are trying to use personal data to come up with individualized prices, terms, and offers. So this is not just prices, right? It's also who gets the discount, also who gets the priority, and so on. And as you now see, right, the advances in technology and AI make this even better. And so today we're going to see how these three ingredients, data, algorithm, and the infrastructure, help speed up this kind of process. And so that's my job today, to try to help get into these machinery. All right, so the first question I want to start with is, why do companies actually want to do this, right? Why do firms actually want to personalize? So let's all be business owner today, right? Let's say we want to think about a simple way to price a product. Let's say we're all selling headphones today, right? Different customers might actually value your headphones as different levels, right? We're going to call this as valuations, right? So you can see these 4 customers, some value it higher, some value it lower. Me as a company, I would try to come up with one single price for the product. So let's say the price is $60. So what would happen, right? How do humans decide on what to buy based on their valuations? So as you might guess, right? If the price is lower than my valuation, I want to buy it, right? I'm getting some benefit, utility from this. And so those who actually have higher valuation than my price would actually say yes to my product. And so let's take a look at how much money I can get, right? I can add up. I can only sell my product to the first 2 customers. The last 2 will not buy my products. I get $120 for my revenue. So there's a couple of things we want to look at here, right? Technically, the first 2 customers, they're valuing our product at a higher price. So technically, they would have been more willing to pay more price, higher price for these products, right? And at the same time, we have these 2 customers who actually get excluded from the product here. So this is a headphone, right? We can think of this as access to services. This could be problematic, right? Some people get priced out from accessing the product or service. And so what do we mean here, right? The challenge in pricing is that if you set it too high, you get some lost sales, lose access. Charging it too low, you leave some money on the table here. All right, so what if I, even in this example, right, I change it up to $80, same 2 people would buy the products, but now obviously I can actually get higher revenue, right? 160 compared to 120 from before. And so one thing you can learn here is that it seems like naturally companies will try to understand your valuations and try to price it exactly where they are, right? Because that's the most you're willing to pay. So one first challenge we already see here, right? It seems like doing one pricing, though, might not be the most efficient because people value products differently, right? So how should we think about this? And that's why companies want to do personalized pricing, right? If we actually know that different people have different valuations, this idea of omniscient pricing is that why don't we set the price exactly at the value? So in this case, I'm going to actually price this product differently for everyone. Would they buy this? Yeah, right? Because actually the price is actually within their valuation. And so all of them will say, yes, they want to buy the product. And so if you add up the revenue again, previously we only get 160 because 2 people was bought. Now we can actually increase revenue by 66% by understanding better how to price. Okay? So the idea here is that we will serve anyone as long as they're willing to pay up to the cost, right? Because the company want to make sure that they still can cover the cost of operating this product. And so this is why, obviously, the main rationale why companies want to personalize pricing. There's only a lot of research recently that talks about when they do it in the field or run some experiment, right? This paper from 2023, they did a few experiments with ZipRecruiter. And so they try to compare what the company is charging customers versus if you do it one single price versus you do personalized pricing. They found that by doing personalized pricing, you can actually increase revenue or profits actually by 19% compared to just doing one price. If you compare to what the company is currently doing, that's even better, right? The status quo, the companies might have a different way of pricing, you can increase it by 86%. But I think the coolest insight I learned from this paper is not that doing personalized pricing improves profit. Actually, 60% of customers get lower prices, right? Remember that when you do personalized pricing, it doesn't mean that the price will go up, right? If some people have lower willingness to pay, and we really want to give them access, that could be one way to do this, right? And in this case, it shows potential promise of personalized pricing. And so if you think of running a business that's worth $10 billion, right? That 19% can be almost $2 billion increase every year. So this is an example of price setting. If you think about the wage setting, it's a very similar story. So I'll bring back my very 4 people. Now they're also driving for a ride-hailing company. So rather than having a willingness to pay or valuation V I mentioned earlier, Now, each person has what we call reservation wage. So I'm only gonna work if the wage is higher than this threshold. And so in this case, let's say these 4 people have different wages. And so if the goal for you as a company to get everyone to come up to work, right, you need to set the wage to be at least these reservation wage. So in this case, I'm gonna minimize the cost by setting the wage exactly as the reservation wage, as long as I get enough people to work for me. Okay, so today I'll mostly show you price setting examples, but you can see the analogy between price setting and wage setting, right? We're going from maximizing the willingness to pay to minimizing the cost, trying to go to the lowest kind of willingness to work. Okay, so yeah, everyone's working. Now, everything seems good, right? If we can actually learn about everyone valuations, then we're done. The problem is, in reality, we actually have no idea how much people value these products. And so how have companies been trying to fix this, right? So think about this. Why don't we try to look at data, right? Historical data for each person, we might have seen them bought or not buy at different prices, right? I can get some sort of estimated value for each person. So let's say somehow from a past data, the first person here, I got their estimated valuation to be $100. Perfect. I can sell it because this person valued it more. But what if I did the estimation not perfectly, right? What if there's some noises in the data, right? I might get too high a valuation for this person, and if I follow my estimation, I might end up not selling to this person. And so by just looking at past data by itself can be quite scary because there might be some noises there, right? And so if you can see here, right, by missing the right valuation, you losing the sales here. Compounding across multiple customers you have, you're losing a lot of money. And so we need to find a way to incorporate uncertainty into the story here. All right, so I'll kind of briefly go through kind of basic idea of how they do this, right? The idea is if you have enough data, you might get a sense of the distribution of the valuation across the population, right? When you get a sense of this, so what you can look at this is the x-axis is valuation, y-axis is frequency. More mean more people have the same evaluation. So this means that if you charge too high, no one's gonna buy it. You charge too low, everyone's gonna buy it. And so we look at this, what I call as demand function at each price. You can see here, right? If you give it for free, everyone is gonna take it. But as you increase the price, you get less and less customers. So when companies trying to get this demand function from data, they wanna think about, okay, at what price then we maximize profit? And so in fact, the way to find profit here is actually to look at the area of the rectangle under the curve, right? So you can move the price around and find where the area is the biggest. That's where the optimal price would be, right? That's what I call P star as the optimal price. Right. Now, what if you want to do personalized pricing then, right? So far, I assume that everyone think of the product in the same way, but you may imagine, right? Let's say for certain products, students might think differently than workers in a company or with senior citizen, right? And that's why we have student discount, we have senior discount, and so on. And so you can also do personalized pricing by trying to understand, okay, what feature or what covariate would actually matter in pricing? For example, it can be geography, right? People in the city might be willing to pay more for a coffee. People further away might have lower willingness to pay, right? And so this X of features can be things like, are you a student? Are you not a student? Are you in the city? Are you not, right? And so once you can identify what features they are, you can actually repeat the same process here, look at the data, and try to see how the distribution look like. And so in this case, right, you see two kind of curve. One is for one type, right? Think about one as for student, one is for non-student. So once you can identify what features impact how people evaluate products, then you can do the exact same exercise here, right? I can do the plot for demand and then try to find for one group, what is the P that maximizes the area? For the other group, what is the P that maximizes the other area? And so that's how companies in the back of their mind try to find different prices for different group of customers. All right. But the challenge doesn't stop here. This assumes that I can perfectly get the curve on the left, but in reality, oh no, actually, we don't have that data in the real world. And so what kind of data do companies usually have? So you imagine, right? It's rare that people are gonna go around and ask, hey, this product, what is your valuation? This one, what's your valuation, right? In fact, if you actually ask people that, they might not even know how to answer, right? So what does the data look like usually? The data normally looks something like this, right? Each customer, you know something about them, where they're from, their income level, and then you might see at what price they saw and if they bought the products or not. So the task here is based on these purchase data, can we somehow infer evaluations of the products by among people, right? And so because we never see different prices, so what we can do is we can look at prices that are close together, right? You can bin the price together, and you can count how many people have seen it. Among those who've seen it, how many actually bought? So that way, you can actually recover back some sort of distribution again. And so rather than demand at each price, it's more at demand for each bins of prices instead, right? Between $0 and $100, what fraction of people want to get it? $100 to $200, what fraction want to buy, and so on. And so the rest of the talk today, I'm gonna try to go over, if you manage to get this sort of distribution, how do we turn it into the price? How does the machine actually work? And so we're gonna step through a few steps, and I'm gonna try to bring in more real examples so that you will see companies around you might be doing this already. So we're gonna see kind of 7 steps. Again, we're not gonna go too deep in them, but just to give a sense of the flow at which how companies take this noisy data and go all the way to prices. All right, the first one, which I think closest to us, right? How does the company collect data from us? So how many of you, when you sign up for a new service, and did you read like the entire, I guess you guys are lawyers, so you might read. Maybe I need some tips on how to read them quicker. A lot of time, it's so small, it's so long that people might miss a lot of these, right? This kind of data has been collected everywhere, a lot of time without us knowing. As I mentioned earlier, right? You can't really ask people to report the price, they might actually lie. So what they're gonna do is use your behaviors, use your data to recover and infer this valuation V instead. So 3 types of data they try to get usually. One is what we call review preferences, what you actually chose to do. So think of it as whether you purchased things or not, your browsing history, what have you been trying to look at, right? Things you add into the cart but didn't buy, right? All the clicks. I think nowadays sometimes they can track your eye movement as well, right? How do they use it? Well, traditionally, you might have these kind of like reward cards, right? Safeway has a reward cards, Starbucks has one. Make sure that you scan your QR code when you buy stuff to get points, but behind the scene, they also collect data of what you get. And you may have seen, right, on Amazon, for example, they obviously track the kind of stuff that you recently viewed, for example. And so your sequence of things you looked at would matter here. I guess this is probably the basic thing we think that companies would try to collect from us, right? Second type is what we call ambience or context. And this is less of what you know that they're collecting from you, right? So there will be things like, your cookies, right, which is like your your browser search and so on. At times, you might have some app on your phone and ask you repeatedly, do you allow them to access your location or not, right? And so sometimes, even if you're not using the app, they might actually collect also where you are. And so this is what we call kind of ambience, things that are not even what you're doing, but things that are kind of on the background. And even more, companies also go further. This is what I'm going to call as external signals, right? You can think of it as even if you're using one app, they might be able to track your behavior on other apps as well, right? And at times, your phone will ask you if you want to allow this or not. And you may have heard of data brokers, right? Companies like Equifax or Axiom, they collect so much data, right? They gather data from credit bureau, they collect data from vehicle registrations, all the way to your magazine subscriptions, right? And they have this entire data set where if companies or retailers link up their data with them, they can quickly expand their knowledge about you, for example. So with the recent advances in AI technology, you would see even more things like in this one. This is Kroger grocery store, right? Have anyone seen this smart shelf before? So they can change the price based on who's kind of around the shelf, right? And they can also track if you kind of look at the price and decide not to buy and so on. So again, not buying can also mean something, right? Progressive actually have something called Snapshot, where if you have insurance with them, you can actually get this device plugged into your car. This way, all the telemetry information like the speed, the route that you took can be reported back to Progressive. And that can actually turn into some price-relevant information, right? So the interesting thing here is that it's no longer about your demographics. It's about how you drive, right? Actual behavior that you did. And so if you got really bad rating of your driving behavior, you might get a little bit, actually you get increase in your insurance premium, versus if you're a 5-star driver, you might get some discount in your premium as well. And last but not least, with AI, right? I think this is an example from Walmart. They have this Sparky AI shopping assistant. Had anyone talked to AI chatbot before? It's kind of fun sometimes. A lot of my students use it. So let's say you go onto Walmart website, right? And you'll be like, hey, I need this right now. AI will actually not only know that you want this right now, but extract a lot of information, right? Okay, the sense of urgency, the sense of you probably have really high willingness to pay, so I'm not gonna give you a discount, for example, right? And so the more you talk to these AI tools, the more they can also learn about your behaviors and so on. All right, so this is one first step, which I feel like closest to most of us. The real other step is how then they took this data and do something. And so imagine that now that you have data from Starbucks reward cards, but also your credit cards transactions, but also your phone usage as well. The hard thing for the company is that how can they combine them together, right? And so they need to find a way to connect through these dots to infer who you are, right? There's two main ways people usually do this. One is called deterministic matching. Basically, just use the information you provided to them. If you use the same email addresses for two accounts, they can try to merge you together. But a lot of time, people tend to not use their real emails, or they have multiple accounts, right? And so there's something called probabilistic matching, where even if you try to, mask yourself from these transactions, they should try to get your IP address, your device model, and similar patterns of your behavior. And most recent research have shown that really close to 90% of confidence you can actually map back to people. In fact, that is actually the lawsuit, right, with this company called LifeRamp that actually basically try to collect data and help companies map across platforms. And I think in the lawsuit in 2025, it said this is the largest and most accurate people-based identifying graph in the world. So it's already happening. All right. So once I can connect all the dots and know who you are, the next step is, can I turn this into information I need to do pricing, right? Can I turn these actions into the relationship to the V, the valuation that we care about, okay? So for example here, let's say you have this data, right? You saw that someone using the app, using a GPS app at 11:43 p.m., and they're about almost a mile away from Subway, right? So this is raw data the platform would get from you. So what can it actually turn into a feature, right? How can we translate it to something machine can understand? Oh, okay, you're gonna get your distance to public transit. We also see the time and the fact that maybe Subway will close soon. We're gonna try to score how urgent you need a ride, right? And so knowing this, they can turn it into something that's more like an action, right? They learn that, okay, this person is kind of stranded, no good alternative, so they have high V, high valuation right now. And so you can think of a bunch of things that they can collect from you, right? Whether you're using an iPhone 16 Pro from Verizon, whether you bought the same cereal 47 weeks in a row. Also from the worker side, right? They can also see, oh, this person always accepts the job all the time, and they work 60 hours a week, and someone also logged in at 2 a.m. 3 nights in a row. What do these mean from the machine point of view, right? You can turn it into some sort of parameters, right? In this case, bought the same cereal all the time, your loyalty is so high, right? People who maybe worked at 2 a.m. 3 nights in a row, maybe they have some financial distress. They try to turn all this information into something quantifiable. And then, as you've seen, right, then we can turn into, all right, what does it mean then for the valuation, right? Someone who bought the same cereal every single week, maybe we don't have to give them a discount. They have really high loyalty already. Which is kind of sad, right? It means that maybe some company would say, oh, wow, these workers accept job all the time. Maybe we don't have to give them more incentive and so on. This is what we call feature engineering, turning the raw data into some signals that help the firm think about what to do next. You may be surprised what kind of things companies can do with this data, right? If anyone wants to use Facebook, right, your Facebook likes can also say a lot about yourself, right? There's an example of how different things that Facebook likes can predict, right? 95% can predict your ethnicity, right? You can even predict if your parents have been divorced using what you like, which is kind of scary sometimes, right? Things that you don't think related at all can actually mean a lot, right? And this is from how your phone calls and app users, or even rhythm of your keyboard typing. What does it say to things like your confidence, for example? Now here's the thing. The platform or the machine try to collect all this data and make sense of it, right? But a lot of time you still see this very neutral algorithm come up with very biased outcome, right? And even if I'm gonna show you here, even if the company doesn't try to discriminate at all, right? If you think about all this raw data, behind the scene of all these data, it encoded some, discrepancy of how people are already, inequality already, right? So zip code might be correlated with race, right? The fact that you can drive every night might mean that you don't have that much caregiving obligation. And so that's why I think there's a recent research paper from economics that showed that in ride-hailing, even though ride-hailing companies never price based on gender, they found a gender pay gap of 7%. Right? Female drivers get paid less, even though it was not part of the algorithm at all. Right? And this is because when you collect raw data, as I mentioned, right, there's a lot of inequality already encoded in it. And that's why the big question we want to ask is how can we make sure we de-bias all this information, right? You may ask why it was the case. They actually found a few things, right? It turns out that male drivers might have more experience. They drive faster, so they can get more trips out. And also, female drivers may avoid some high crime areas. And so that's lead to lower pay. Again, the algorithm didn't do it, but all these behind the scenes stuff. All right. Step 4 is demand estimation. This is actually recap what we saw earlier, right? If you have that distribution curve, you can try to get back what the demand curve looks like. And so again, the idea here is that now, at different prices, how likely are you gonna buy? And so the question here is, can I give you information like the current price, and a lot I know about this customer, can I predict whether they're gonna buy or not? This is where machine learning is really good for, right? You may have heard of some of these tools like logistic regression. They try to map features like, age, gender, price into a binary decision, buy or not buy. There are things called k-nearest neighbors, which actually help you cluster behaviors. And so this is interesting because you might actually sell a product that you never saw before, but you can actually learn something from similar products, right? Let's say I always sell red headphones. If one day I want to sell a blue headphone, I can actually find that, oh, blue headphone is very similar to red headphone. I can use data I collect already from the red one. And some other tools that I'm not going to go into details, but just to give you a sense of now, in the earlier days, you actually have to determine which features matter, right? Maybe for this product, whether your student is important, the age is important. Nowadays, with limitless amount of data, these tools like gradient boosting or neural network, you just throw in the data and they'll figure out for you how the data maps to the decision, right? So if I come back to this data set I show as an example, right? There's one caveat here, is that I assume that I do have data at different prices. Imagine that if you already give one price so far in the past, how can you recover back demand information, right? So if you have been changing prices, that's good, right? But if not, that's why a lot of companies want to experiment on prices, right? And so if you think about if you have subscription to streaming platform like Netflix, for example, right? Some people get the subscription but never really watch it. Netflix might try to see, okay, they're gonna predict who likely to keep the subscription. If they think that you're gonna stop subscribing, they might send you a coupon. And so if they've done something like that, they might see what fraction of people who get a coupon actually stay or quit, right? Let's say they have this result and found that 65% of those who get a coupons quit it. What does it mean here? Does it mean the coupon didn't work? Or was it because these 65% of people were already quitting anyways, right? And so this is what we call confounding, right? When you try out and experiment different prices, different coupons, but people might have some underlying mechanisms of their behavior that you didn't observe, right? This person might want to quit anyway, so by giving the coupon to them, it doesn't work. And so this is why when companies try to run experiments, the golden rule is randomization, right? We want to make sure that when people get different prices, it's because of randomness, okay? So one simple tool people use is what they call A/B testing. You guys might have heard of this term. Basically, they try to, decide what feature to change, right? Let's say you keep A as a control, things doesn't change. You can say, I'll give fraction of my customers a new change. So I call it as the B group. I might determine what is the metric I care about. And if it turns out that A or B improve my metric, I will choose to go ahead, right? Let's say B is really good compared to A, I might launch this new feature. So very recently, you have seen companies doing this, right? When Google tried to decide what shade of blue to make the color of the link is, they actually experimented with like 81 different colors without you knowing. Which blue you actually click more, and so on. Now, if it's about color of the link, it's not that harmful, right? But if you imagine, this could also be pricing, access to a service. Recently, you might have heard the news from Instacart, where they acquired a company in 2022, right, that did a lot of price experiment, where you might go to one location and exact same time, exact same location, people might get different prices for their eggs, right? Of course, from the business perspective, right, the point of doing this is for them to collect more data at different prices, so then they can better get a sense of your evaluation. But of course, there's a lot of consequences, right? And obviously, you can see, I think at the end of last year, they already said they stopped doing this already. And so I will show you one example of an idea of what if you still want to do this, but try to care about the fairness a little bit more. So DoorDash has something similar, but rather than giving everyone at the same time different thing, they actually give everyone at the same time the same thing. But they're going to change it over time. So that's what they call switchback experiment. So this 1 hour, if we all go to the restaurant or to the store, we get the same price or the same feature. But maybe 2 hours later, they're going to change it for everyone. And so now the unit of randomization is not by person anymore, but it's by time instead, right? And so that way you can reduce, again, I'm not saying that we throw away all the fairness issues, right? But it makes sure that at the same time, people get the same deal. And you can still get variation in prices through observing them over time, right? I'll speed up a little bit as we're short on time. But the rest, right? Once you have all this information, then you do the same thing. Pick the P that maximizes that area of the curve I show you. One example that you may have seen a lot is airline pricing. If you fly a lot, you might have a favorite website to look at it. I'm not sure how many of you have like a perfect time to buy a plane ticket, right? The company is actually doing something like this, right? If you think about airlines pricing their seats, these seats, I would call them as they are expiring, right? They're like deadlines. If the flight already departed and you didn't sell out the whole plane, you can't go back and sell the seat from yesterday, right? And so companies have to think about how can I fill up all the seats by the time the flight left? And so they would do the same thing that you might imagine, right? They're gonna do pricing, but now in time instead, right? If you bought early, like 4 months ahead, it will be the cheapest one, right? For people who have maybe low V, right? Low valuation. As you get closer, it can be more expensive. This might be for business travelers who, they can get it reimbursed, so they have really high V. And you're gonna keep a couple seats for people who like really need it, right? Last minute. And so that's why you have like different buckets for this. And this is how companies like airlines, hotels, where you can't go back to sell yesterday rooms, will always do something like this, right? They call it yield management. In fact, American Airlines invented this in the 90s, and they showed that they increased almost $500 million annual revenue by just doing the pricing based on how much people are willing to pay and how far ahead they book things. Now, I show you so far mostly the price part, but you can imagine, right? The weight is gonna be the same thing. Rather than try to pick the max price, you now pick the min wage. Again, it sounds kind of sad that you minimize the wage, but I'm, again, telling you from the economic point of view. All right. The last two steps is pretty simple. This is basically, now we optimize all the prices. How do companies actually send them to the customers, right, or workers? And so obviously to make this really dynamic, they have to give you real time, right? And so for example, whenever, let's say you are a driver, you log onto the app, it will ping the server and say, this driver, where they are, what time, wanting to work right now. Now, all this optimization, right, even if AI and computation is really good nowadays, they can't really compute this on the spot. And so a lot of times, this is why browsers have cookies, or this is why on your phone, you may say like, I delete all my photos, why I don't have any space left, right? All these apps try to record your data usage. A lot of times, without you knowing, companies might actually try to do the optimization I show you, even when you're not using the app. So that when you click on the app, it will already have some good sense of what price to give you, right? And so it will retrieve some pre-computed prices. And then, of course, they can try to do re-optimizing again, get a better price, ping back to you, right? And this is from a ride-hailing example. You might get a personalized prices for different regions. And here's the last part, right? Now they deliver the price to you. The job for you is to decide, am I gonna take this job or do I gonna skip it? And so your action will be logged and sent back to the platform. So that's the last step, which is the feedback loop, right? Very similar to how I show you feature engineering. So there's a bunch of things that you might do, right? You might choose to buy the product right away. You might browse for 5 minutes and buy. You might view, but not buy later on. Your actions here can help them recover back the demand function, right? And so for example, if you buy it right away, the demand at that price is 100%, you're gonna buy. Or if you view and you leave, then the demand at that price is 0, and so on. And so if you can recover back the demand function at this price, then you can decide, all right, if people buy right away, no need to do discount, they like the price. Or if no one actually bought at all, maybe in the future, we should reduce the price on. And so this is what I call the last step, but this is actually the step where it's gonna be the cycle back to the beginning, right? I collect more data, let me collect more data from you, and then I'm gonna re-optimize this over time. And so this is actually the cycle. So putting this together, right, you can see all these, but these seven steps. What make it, I think, more advanced, but also more challenging nowadays is that we have been doing this for a long time, right? When you do the coupons, it's the same thing, but it might take you years to do this. But now with the AI and the tech, the app, you can do things with more precision, right? So I would say like the main change right now is precision. You now have the LLMs, you have AI that make sure that even if you have like a subtle note in your ChatGPT prompt, they might be able to know what you want to buy, right? Or we now have tools like wearables, right? Apple Watch, Whoop, where it constantly gives you real-time health and behavioral data, and so on, right? Or we all have maybe home tools like Alexa and so on. And so let me kind of summarize and end things here, right? The whole thing I want to tell you today is that this idea of dynamic pricing or wage setting is not new. Companies have been wanting to do this forever, but now they just have better tools to do this, right? Not just better tools, but they also have better data to do this. And so thanks to AI, right, they can do all of these things. So what I think things can go forward, right, because now computation is cheaper, right? Even my parents now can use AI and make websites, right? Cheaper to infer things, cheaper to compute things, right? Which means more and more companies, even mom and pop shop, might kind of leverage all these tools more. Again, we have more denser data, right? From LLM tools, from wearables, as I mentioned earlier. And last but not least, I didn't get to mention too much today, but we already seeing this beyond just gig economy, right? Not just ride-hailing drivers, but also even people working, right? You can think of companies deciding which training to give you to do next, and so on, right? So this is already happening outside of the gig economy. And so the open question I want to leave with you guys today for the rest of today is, I'm not saying that this is a bad thing, right? We saw earlier that dynamic pricing can be good. Some people get lower price, which means we increase access. If you think about surge pricing in ride hailing, if we don't do surge pricing at all, then some customers have to wait the whole month to get a ride, right? Because think about this, pricing is a mechanism that makes sure that demand and supply can match in real time. And so if you want a platform or the system to be sustainable and feasible and run smoothly, we need this mechanism to make things work. But the question is, by doing so, someone get more access, some people lose access, some people have to pay more, or some people will be treated unfairly. And so I think the question is not about should prices be personalized, but it should be more how should we do it better and fairer for everyone. So thank you so much for having me. Yeah. Thanks.
Yeah, thank you so much, Professor Park Sinchaisri. Thank you. So we have a 10-minute break now. Everybody, please return to the room at 9:40, or 10:30. It's 10:20 right now. So return at 10:30. And just a reminder, part of the reason we had everybody come here is so that practitioners, academics, students can all meet each other. So take some time in the break to chat with somebody that maybe you don't know. And yeah, we'll see you soon, and we'll get started on the first panel, which will be on prices at 10:30. 5 minutes? Okay, in 5 minutes.